Hey guys, today's episode is sponsored by Westermeyer Industries serviceable oil floats. Many oil separators contain an oil float to effectively meter separated oil back to the compressors. Westermeyer Industries has taken this concept and perfected it with their new line of serviceable oil floats. These floats feature an improved design with fewer components, allowing for greater manufacturer consistency and up to 20% increased oil flow versus their legacy models. These floats also feature an integrated magnet to shield the oil path from debris and have been field proven in supermarket applications. Westmeyer Industries offer replacement oil floats not only for their own separators, but also cross-compatible models for our competitor oil separators as well. You can find out more about the Westermeyer Industries serviceable oil floats by visiting westermeyerind.com/floats. Once again, that's westermeyerind.com/float. Let's get on with the episode.
Hi, guys. Welcome to the Advanced Refrigeration Podcast. I'm your host, Kevin Compass. I'd like to take a minute to talk about one of our sponsors, Parker Sporlan, and thermostatic expansion valves. How can you guys always have the right thermostatic expansion valve for the right application without having to carry hundreds of valves in your truck? Well, that's simple. Using Sporlan's interchangeable cartridge style valves. The Q valve for conventional and the BQ valve for balance port. It's as easy as one, two, three. It serves thousands of unique applications. So, one, you just select the thermostatic element for your application. Two, you select the body style you need. Three, you select the right size cartridge for the application. These easy to select and assemble valves mean you always have the right valve for the job on your truck. For more information on the Q and BQ valves, visit sporlan.com. Thanks, guys. Enjoy the episode.
Good evening, everybody, and welcome to Advanced Refrigeration Podcast. You hear the host, Brett Wetzel, Kevin Compass, and we have a special guest tonight with Honeywell, Ed Curran. How are we doing tonight, man?
I'm doing well. How are you guys?
Oh, living the dream. Can't wake up, man. Kev, you having a good week?
Yeah, not too bad. Just some gravy, all these startups for once, and not pulling my hair out, and I'm actually not out of town for once.
You look good. This week you don't look like hammered dog shit.
Thanks. I'm only going to hit 65 hours this week instead of 90.
That's great.
Wow,
Yeah.
that is the dream.
Yeah. Feels weird.
So, Ed's going to be on tonight talking about Novar. We're going to talk about some older legacy stuff, some of the newer stuff, the ES1s. Ed, why don't you start by telling everybody about yourself?
Yeah. So I'm Ed Curran. I work for Honeywell Multisite. Honeywell Multisite is we own and deliver the product line that is Novar, among other product lines. We have two main offices. One is in Cleveland, Ohio. They manage retail space applications, so HVAC and lighting primarily. We also have the Bentonville, Arkansas office where we manage grocery retail. So that's where most of our technology comes out for refrigeration. Just a quick history on me. I started out in hardware and software a long time ago. From there, I went into telecom. Then I went into EMS. From there, I went into refrigeration commissioning. I did that for Novar for 7 years. Honeywell ended up hiring me to become a sales engineer for the refrigeration OEMs 4 years ago. 2 years ago, actually about a year and a half ago, I started leading that team. So I'm now a supervisor for the technical support team or the technical sales support team for both offices. So sales engineers and estimators. So I'm a little bit removed from the day-to-day out in the field, but overall, I still have a really good sense of what's out there, what's coming, a number of problems that, we struggle through and try to resolve those before they get too far along. So I appreciate you guys having me on, by the way. Congratulations to both of you. I read about you in the 40 under 40. That was pretty awesome.
Thanks, man.
I've listened to a number of your podcasts. They're informative and entertaining, and I appreciate what you guys are doing for the industry, because one of the things that I really value is just getting knowledge out there for our equipment, and seeing you guys do it for just everyone that's out there it's really great. The more people understand our stuff, the better. So thank you.
Not a problem. It was funny because someone asked Kevin the one time. He's like, "You do a podcast, right?" And he's like, "Yeah." He's like, "You do it with a guy from Cool Sys. Why?" Because it's a small industry, and everyone's fighting to learn something. So why not help everyone out? You know what I mean?
Yeah.
I still don't know why.
Shut up.
It is a really small industry. I mean, especially with knowledgeable people. I mean, you see a lot of movement from one company to the next, but you see the same names over and over and over again throughout. So, I mean, you have to appreciate that. And I think that's part of the reason why, even when we're talking about competitors, we typically treat them pretty well, because you never know who's going where in the future. So,
Absolutely. So tonight we're going to start off talking about some communication stuff with Novar. Do you want to go back as far as how far?
We'll go back as far as my memory serves, because the stuff is pretty old. Novar's been in it, I imagine, close to 50 years now. They started in HVAC and lighting with their Logic 1 controllers, which would be in the refrigeration world, we would see those in the stores as EPs or EP2s, the executive processors. So their network was called Logic 1. Probably, I imagine it was about a decade later, they went into refrigeration at the request of one of their customers, and they created the Spectrum network. The Spectrum network is a refrigeration network. The executives on that network would be your refrigeration controllers, your RC or your RC2XE. What's interesting about those is in this system, your executive processor, your EP, your EP2, which would be in your EDC controlling HVAC and lighting, it's going to be your gateway out of the building. So with RCs and RC2XEs, you're going to have a slave LAN wire going back to that EP so that it can call out alarms and communicate out of the building.
So basically, you're going from the case controllers to the main refrigeration controller through the LAN network that goes out to the EP. You said, which
Yeah,
the HVAC controller that sends all the alarms out.
That's it. So sensors to refrigeration modules to refrigeration controllers communicate through a daisy chain back to the executive processor controller in the EDC, which then sends out alarms for the entire system. So you have one controller sending out alarms for the entire store. That comes in. It's a serious consideration when upgrading these, because when you want to upgrade one rack controller, you have to continue to maintain that daisy chain from the other one so they continue to call out alarms. So if you remove it, you still have to tie off those RS-485 wires just to maintain that network. From there, we started getting into some LAN communication for munters. That's where you're going to start seeing your XEM10s. That would be the first Opus controller that you would see in these buildings. That would be in the EDC near the EP or EP2. It's going to be mounted on the wall. The only thing communicating to it would be munters via LAN. Shortly after that, Novar expanded into BACnet Opus systems, which includes the XEM20R and most recently the ES1. So the XEM20R followed the previous designs, which is a compact solution. It's got a transition board. It's got input and output on board. It's got an LCD. It's a self-contained unit. The ES1 is, well, really the XCM10 was our first modular system. The ES1 followed up on that. For people familiar with Tritium or Honeywell in general, this would be a Jace controller. So the ES1 is a Jace 8000 underlying technology. So I personally prefer a modular system over a compact solution, primarily because as parts fail over time, you can swap them out. I understand why customers prefer compact solutions, because you take the thing off, you put one in, you have a whole new assembly. It can be an easier installation. So there's benefits to both, but that's sort of the short history of our executive controllers, or our primary system controllers, or our PLCs, if you will.
So, sorry.
So on the ES1, for example, that'd be a modular system basically, where you could pull it apart and add COM rails to it and everything else.
Yeah, so the ES1's DIN rail mountable. It has 2 RS-485 ports on it. You can expand it up to 7 ports. You can add 4 more RS-485 ports and a LAN port. That would be pretty much the maximum configuration.
Yeah, they use Jace controllers predominantly on HVAC. A lot of buildings use them because they're expandable. You can talk to different manufacturers using one particular controller.
Yeah, so that's been the biggest driver for this technology. Is we're seeing more and more systems where they want you to integrate to everything in the building, and when you're dealing with BACnet, Modbus, LawnWorks, RS-232 systems, when you're trying to incorporate everything in the building into a single controller, you need that versatility. The benefit of having a Tritium powered controller is that all of those protocols are supported on the ES1 right out of the box. So it's pretty powerful. On the XCM20R, most of those, a number of those protocols, you have to pay for an advanced license for each one. And they got away from that just in the way that they structure their purchasing system. But all protocols are supported right out of the box.
So you don't have to buy any special license. So if you want to hook up to a Munters unit that has a Corel controller, or if you want to hook up to this Danfoss drive, there's nothing else that you have to, no licenses you have to purchase.
So Danfoss is special because it's got a proprietary system. So for that, you're going to purchase a license. Okay. It can be integrated. We've done some retrofits where we've replaced everything in the rack house, but we kept the case controllers. So we integrated to the case controllers, took out everything out of the rack house.
So you guys are actually communicating with the Danfoss case controllers?
Correct. We have some systems that communicate with Emerson devices, some to Danfoss. Now it's easier with the open controllers, your Corels and controllers that are designed for integration, or at least come at it from an open perspective. It's much easier to do those integrations. But we do have a number of integrations to competitors, whether they're proprietary or not, which, I kind of get a kick out of that, because it was probably, 5 or 6 years ago, I went to a trade show. I saw Emerson had integrated to our legacy boards, but we were probably 2 or 3 years into having XIO boards, which are open BACnet. So yeah, it's kind of little and late, but we all do it. So
no, I remember having to do. Kevin's done 1 or 2 of them too, where you basically had to take the old legacy boards and hook them up to an E2.
I was the first one to do one that was outside of Walmart.
Really?
At a Walmart, it was actually in that rack house that we were just talking about earlier that caught on fire. We ended up dropping that behind a store because their rack house fell inside the building.
I remember that. I remember the pictures.
Glycol rack and everything fell in the dock. The whole thing collapsed. We ended up dropping that rack house from that Walmart that caught on fire that we bought for a training unit, dropped it behind the building, and I threw an E2 on there because it was an Opus controller and it had no program in it. And I ended up having to, use all the old Novar boards in there. Wow. So I ended up having to get the license for it. It was a nightmare trying to convince Emerson to give it to me because there was no price on it because it was all through Walmart. Like there was a special through them. So
You got to make it work, man.
it was a cool little project.
Yeah.
Oh yeah, yeah, I'm sure.
So on the older Spectrums, let's start with that. There's what COM ports are on there, and usually you guys designate certain COM ports for what you guys hook up to. You want to get into that a little bit?
Yeah. So on our legacy systems, you're going to have. Let me see if I can pull up a note on that real quick so I don't get too thrown off. You're gonna typically have. I believe it's on the Spectrum side. You're going to have 3 COM ports, A, B, and C. On the HVAC side, you're going to have A, B, C, and D. The HVAC and lighting side, I'm not as familiar with. I'm willing to bet I have an old architecture drawing on that, though. Let me see. So on that, you would have on your first COM, you would have your MinIOs, NSDs. Actually, that's probably not even accurate. I'm just gonna skip over the HVAC and lighting side.
Yeah, everyone's listening here for refrigeration anyway. Go ahead, good.
Yeah, so we'll get to the meat of it. So on the refrigeration side, your primary boards, your primary rack boards, your compressor output module, your rack output modules, those are going to be on your first COM port. I believe it's COM A. On the Opus boards, if they've already been transitioned, it's going to be COM 3. And your second COM, which would be COM B or COM 4, that's going to typically be your condenser. I don't know at this time why the condenser was split off. In fact, you could combine that condenser back with the first COM if you had to free up a COM in a future install. It could go on that first COM. So your primary rack things are going to be on your first COM, your condenser on the second. Your third is going to be either your CMSs or your CIMs. Your CIMs are going to be powered from the executive controller. So you're also going to have 24 volts, I believe it's DC, going out to your CIM boards. So when upgrading those, you have to know that you're going to need if you're going to an ES1, you're going to need a power supply for that, a 24 volt DC power supply. That's kind of a gotcha. We do have, by the way, if anyone needs it, we do have documentation that goes through upgrading any of these systems to an ES1, basically a step-by-step guide in each instance. One thing to keep in mind with these older systems versus the Opus systems, Novar Legacy, one of the things they did to stay proprietary is they mislabeled their positive and negative on their base plate, on their transition board. So when you wire positive off of the module to positive on the transition board, you're actually wiring it. You're actually wiring it backwards. So you're going to the negative. So I wasn't with them when they did this. My guess is it would make it harder for a competitor to reverse engineer your solution. But what that does, anyone that's familiar, when you're hooking these up to an Opus system where we no longer do that, your XEM20R, your ES1, when you land these legacy Novar boards back at the executive, you need to reverse the polarity. So if it's positive on your board, on your modules, it has to go to the negative on these updated boards, on the Opus boards. So that's something that it's really a wrench into everyone's plans. But when you're wiring those legacy boards to a brand new controller, you want to reverse the polarity. When you're wiring to our modern XIO line or any BACnet device or Modbus device, any other device you're connecting to, it's truly labeled the way it should be. So it should be positive to positive, negative to negative. But on those legacy Novar modules, it needs to be reversed at the executive. So when people change them out, they often swap them over and they go, nothing's talking. And it's like, reverse the polarity. So that's like rule number 1 with those legacy boards and an upgrade.
Having to switch it around with the polarity.
Yeah. So you'll end up with the legacy parts being reverse polarity, and then on the newer equipment it'll be straight polarity. So it kind of throws guys off why you, you're looking at it and you're like, all right, I have whites going to positive here and I have blacks going to positive here.
And it's
like, what's going
the
on?
black labeled mid-IOs you got to reverse too? Or is it the white labeled mid-IOs?
The older ones. I believe it's the white ones. And then they got away from that. They said, why are we doing this? And they stopped. So we don't do that with equipment moving forward, but that is something from the past. I think something else that people should know is on these legacy boards, there's two ways to address them. They're either going to be addressed with dip switches, or they're going to be addressed via jumpers. It's important to know that on those dip switches, and this is something that we continue to today, we don't address on, we address off. It's a binary addressing, but it's in the off position. So
it always throws everybody off.
We are consistently keeping that. So not my decision, but it is what it is. One thing I tell techs all the time is when you're replacing a board, when you go out and a board's burnt up and you just have to put in a new one, look at the board before you swap it out. Look at all jumper configurations, all dip switch settings on that board. There may be multiple because some of them may be configurations, but look for them and then make the new board match it exactly before you swap it out. And your likelihood that it'll come up running is much higher.
And that's the other confusing thing. Like I've seen that, the guy asked me, I was like, why are there so many dip switches on the board for the comm? I was like, well, you're used to E2, right? We can go up to 64 boards on E2. Novar, what is it, 100 and what?
Well, it's tricky because legacy Novar, each module has a specific range that it accommodates. Everything is pre-programmed. Those systems were designed. They're kind of nice because they were designed for their application. So you have a compressor output module. That's what it's doing. You have a rack input module. It's designed to take all the rack inputs on it. The nice thing about that is you get away with having one board do a lot of functionality. But a compressor output module, for instance, I believe you can only have 8 of them on a system. So, or maybe it might only be 4 actually. I think it's 16 to 20.
Don't get me to lying.
So
what is it? You know what it is, Kev?
16, 17, 18, 19, I would guess. I can pull it up. In fact, I don't know. Some of the older guys have these because they used to give them out in the courses. Have you guys seen a hardware reference guide from Novar?
Yeah, I have one in my truck.
Do you have an up-to-date one?
Absolutely.
I should probably supply you guys with one of those. I can at least send you a digital copy to get you going. It's getting very long because we've been adding a lot of equipment to it. But
the last one. Go, sorry.
It's basically a shortcut that shows you all jumper configurations, dip switch configuration options, where you're going to be wiring things to, what's available for wiring.
I think I have the updated one because I think that involves the Spectrum XIO boards.
Okay, yeah, that would be up to date.
Yeah, mine's when the XCM20 first came out. It's a little
outdated.
Yeah.
No, so a lot of the Spectrum boards, if anyone doesn't know, a lot of the Spectrum boards, condenser output modules, compressor output modules, you can't get them anymore. They don't retrofit them. They don't make the parts for them anymore. So Novar, Honeywell, they've derived a board that basically speaks on Spectrum network that is basically an IXO board. So I think the only difference in the part number, it'll be like an IXO something output, and then at the end there's an S for Spectrum, so you know that board actually talks in the Spectrum network, correct?
Yeah. So what happened was we hit a wall with parts, right? You're trying to get parts to make a board that was created 40 years ago, and suppliers are like, these parts don't exist, nobody uses them. You can't keep buying vacuum tubes and things like that. Like, those parts just don't exist. So what happened was we hit a wall very quickly where we were just told, hey, we can't keep selling this stuff. We can't make it. We physically cannot make it. So what we did was we already had the XIO line for BACnet. We got with our engineers and we had them basically build an emulator in that board to emulate these older legacy boards. Now it's not perfect because the form factor is different. So when you're dealing with a rack input module, like I said, it's built to take on every input in the rack. Well, XIO boards only have 8 inputs, so you can't do that. The rack input module would have had about 24 to 30 inputs. So what you have to do is if you need to replace one of these legacy boards, you need to basically, you could end up with 2, 3, 4 boards to do it. It's not a great fix, but it is a great workaround when a customer doesn't have the budget to upgrade the entire system, at least not at that moment. You can at least send them something out where they can get it up and running. There's a lot of configuration options on them. We have an installation manual for them. We also have kind of a comparison guide with the Spectrum equipment so that you can compare the two when you're swapping them out, what kind of challenge you're going to be in for. We always recommend upgrading to an Opus system so you can actually use the BACnet XIO, which have much more versatility and programming features to them. But the Spectrum XIO are available, especially, if you lose like an analog output module, you don't want to necessarily replace the whole system. And you can replace it with a single board. So there's a lot of uses for them. We sell quite a bit of them. But overall, I mean, the long-term goal should be to try to get that executive controller upgraded to really start utilizing some of our other boards, which have much more functionality and benefit.
We should definitely post like that link for all that stuff on when you post the podcast, Brett, because we've been running that a lot lately, not being able to get condenser boards. So, that's going to be a huge thing. I mean, it seems to be the condenser boards that failed the most here recently.
So condenser boards, I believe, what are they replacing them with? I believe it's an XIO RIM and an XIO ROM, I think, are going in there for those. If you guys want that, I actually have a handful of kind of generic drawings as to how to set those boards up for some of the applications we've been seeing repetitively. I've just gone ahead and thrown together like the best solution for some of them.
I mean, that'd be great because, I mean, it's been happening a lot lately. So, I mean, a lot of guys would benefit off that, seeing that than running everything in full.
Today's episode is sponsored by the new Refrigeration differential pressure monitor from Westermeyer Industries. When the filter element of your coalescing oil separator is contaminated, it can hurt your system's performance and efficiency. But how do you know when it's time to replace the filter? Wait too long to service the filter, and you could end up with nasty filter blowout. But replacing too often can be a waste of time and money. The answer is installing a differential pressure monitor. The new Refrigeration RDP-01 differential pressure monitor is available now with Westermeyer Industries. To find out more, email sales@westermeyerind.com. Once again, that's sales@westermeyerind.com. Look for the new pressure differential monitor, available now.
Yeah, no, I understand. I'll get that stuff over to you. I'll send you guys a trove of information and you can pass it on to people. When I started with Honeywell, my goal was to support the OEMs, make sure they knew what was coming out. Since I've taken on this newer role, I'm kind of expanding that to just try to cover as much information as we can. Useful information, pertinent to what's actually out in the real world. So it's definitely available. I'll send it to you guys. You can pass it along as needed.
Absolutely. The next step after the Spectrum that you said was which one? That's the Lingo style controller, or not Lingo? The more web-based style.
The RC2.
The RC2XE.
Yeah.
So the RC2XE runs on the same software as the RC. So it looks more advanced when you navigate through the web views on it, but it actually had it had most of the same software under the hood. It was an updated version, but it was still running on very similar software. I would say part of the reason that had to go is with, I mean, with that old of software, you start running into security concerns and other issues with it. It's not. I wouldn't say it's a risk, but it's aged, and you don't necessarily want that older technology floating around out there.
One thing I really liked about it is, when trying to deal with communication issues, that gave you the, I want to say comparator, but I know that's not it.
It's got a built-in oscilloscope in it.
Yeah. Well, the oscilloscope, yeah, but there was also, Ed, what's the amount of faults that it has? I can see it, but I can't.
Com count up.
Yeah.
Comm loss.
Yeah, but it was called
comm
something
loss
else.
alarm.
But it's a number that basically they can see how many errors that it has. So you can kind of see, like, wherever it stops and starts, like, as far as, like, let's say, you have zero comm failures from these controllers down, and then it starts really comm failing.
Oh, okay. Yeah.
I can't think of the damn thing at all.
That's actually that information is actually available in Opus as well. It's just not visible through the LCD.
Well, that's what I mean. Like, I was dealing with a comm issue with you. I was beating my head against the wall, trying to figure out, what was going on. And, I finally, we went through the whole, all the case controllers, all the RCCs, got rid of every star configuration, everything that would have caused an issue. And lo and behold, we were having cases that weren't going into defrost. They weren't going into defrost because we had another star configuration on the primary loop on COM A loop, but it was so bad it was actually causing miscommunication with the case controllers. So because the way the store was set up, you basically had EPRs, electronic EPRs that were being controlled off of the COM port A, and the temperatures and stuff were being delivered back from COM port B. So you had beat the fact that you had COM issues on A was actually causing the case not to go into a defrost, like not even commanding it to be on.
Right.
But having that count was really helpful because basically I could, once I figured out something that was wrong, I could basically, call Novar, have them reset the counters and see, if the counters started increasing again or if it just stayed at a lower level. It kind of gives you, coefficient.
Thank you.
I knew it was in there somewhere, man. I looked at it 100 times, man.
So yeah, one thing I would say about that whole deal is the LCD on the XEM20R has never been a big seller, especially coming off of that RC2XE. I know it was a point of contention with a number of techs. Another thing that happened at the same time was the customer asked us to make it so that you could not override inputs, which was another point of contention because it eliminated the ability to force things by manipulating different values, which made it harder for the techs in the field to do their job. Now, I understand why that's a benefit to the customer, because when you do an audit on an old store, nothing is programmed the way it should be. Like nothing. Like you have 100 times where techs have gone by and a handful of them touch the wrong thing and change some set points, and the next thing you know, you're wasting a lot of energy. The system has band-aids on it instead of fixes, and you're not controlling your environment the way that the customer wanted to. So I understand why they locked it down. That LCD we have doesn't necessarily need to be programmed that way, but it's what the customer wanted, and that's what we did. We did recently, we started opening up set point change opportunities in there where it will change set points. I think it overrides them for 24 hours. So you could override it and then call it in and say, hey, make this change permanent. So we've added some functionality back into it at their request. But what I was getting at with this LCD overall is we've spent the last year redesigning a view for these systems. We're not sure exactly how it's going to be deployed. Initially, it's going to be basically a web view where you'll log in on a tablet or your phone, and you'll be able to navigate through it and see different set points. What I would say about it is we did a lot of voice of the customer communication and review, where we actually brought techs in and asked them, does this make sense to you? Do you know where to click? See if they can intuitively find what they need. But bringing up the coefficiencies is useful, because that's something we could potentially add in there, is just maybe a marker of health for the comm. Another thing I would say is those older Novar systems were very friendly to star configurations. It's something that is very difficult to maintain with modern hardware. Modern hardware is much more specific with the way data is transmitted. So it's not as forgiving where star patterns will work. So that is a big challenge on some of these older stores, where you could wire from one board to the next without any regard to which way you were going. And now it has to be a true daisy chain. So, which can be very costly to rerun those wires.
Well, a lot of the as-built and stuff, I mean, they basically tell you, when you're pulling out this case, the new comm line should be from here to here. Whether that gets done or not is another story,
Right.
These as-built you speak of, I've yet to see one with that.
I've seen some drawn up in Sharpie, hidden behind a wall somewhere.
Yeah, usually it's my electrician drawing them in Sharpie with question marks where he thinks he
the
ran
third or fourth layer of Sharpie gets a little difficult to read, but you can figure it out if you use your head. It's challenging. Old systems are challenging. I mean, you walk into them, and if it's not your store especially, you're going to be doing a lot of guesswork. I mean, it's, that being said, I mean, you can sometimes ask the customer if they have anything. Those as-builts, though, you're right. They're not logged anywhere where anyone's going to retrieve them. You can either get lucky and find them stashed behind something, or they don't exist. So,
Ed, one thing in the RC2, I get a lot of questions about this from guys. So in the RC2, when they're doing EPRs, the early stages, when they're using the analog output boards to drive the Sporlan IV boards, okay, a lot of guys will look at it and they'll see the cut in, cut out, like the old school Novar. You get your cut in, cut out temperature. Where is the actual control value? If you can go over that so guys can understand it, the control value for that EEPR. Is it the middle of the cut in, cut out, or is it some magic number? Because in the RC2, it does not list it.
That's a good one. I honestly don't know. I can dig that up for you, but I don't know that offhand.
Sorry, I didn't mean to throw that one at you.
No, you know what? It's a good point. I'm trying to think back when I was commissioning those. That's a tough one. I'll ask someone that has been programming them more recently where that
I always forget to ask Lonnie every time I talk to him.
I'd rather tell you something right than something wrong. So I'll circle back and get you that one. But yeah, that's I don't know. We'll have to revisit that one.
Way to put him on the spot, Kev.
No, it's a good question. It really is, because it's not clear. I mean, when we control EEPRs, we're usually controlling just off of the temperature. So controlling off of these cut-in cutouts, that's a good question where it falls. I would guess the average, but let me confirm that.
Yeah, I would think it'd be the average, but yeah, I get a lot of questions about that. But yeah, we'll move on from that one.
Yeah, that's fun.
Kev, I'm waiting for more questions. I know you're biting your tongue here. Come on, you got to have something here.
Yeah, I mean, let's see if I can get any of them.
Yeah. Okay, backnet comp voltages for you guys. Like, what do you guys want to see for backnet comp voltages? If you kind of want to go over that.
Yeah, so if you look at the legacy COM voltages, you're looking at 5 volts split between the two sides. Really, it's going to be like 4 and change. One side is going to be heavier than the other. It's going to be like 2.8, and the other side will probably be like 1.6, 1.7. On a backnet COM, it's going to be a little bit different because it's not a loop of communication the way that that Spectrum board was. The Spectrum board, it was like it was sending a signal on one side and it was coming back on the other. BACnet's communicating in a different way. So what you're going to see on there is still a split of about 5 volts DC, but you're going to get about 2.5, 2.2, 2.3 on each side. What I would look for is if you're seeing a high voltage on one side, anything over like 3 volts really, or if you're seeing anything where it's zeroed out on a BACnet loop, a zero out, you're grounded somewhere. And if it's higher than 3 volts, you probably have something feeding into it. So it's not as clear cut as the older systems were, but you can still get a pretty good feel for it. And it's I mean, when you guys troubleshoot lines, I'm assuming you're bifurcating the system, right? So you're splitting it in half if you're trying to find out where it's down. So you're going to split it in half, split it in half again, split it in half again. If I was doing that with a meter, I would just be looking for roughly 2.2 volts on each side for BACnet. That would be healthy.
Okay. Try to think what else we can go over. So we've had this problem a lot with like the XCM20Rs with them freezing and not rebooting. Is that thing pretty much just toast? I mean, it seems like they have to go in and shut down the customer's polling. I don't even know if you could talk about this.
Well, so yeah, the only thing you can do when you run into a system like this where it's failing and it's locking up, you have to go through the right channel. You have to call support. You have to escalate it. They're going to review. I definitely don't reboot it. It probably already has been, but if you go up to one and it's hung up, don't reboot it yet. See if they can access it remotely first, and see what tech support does. If they tell you to reboot it. But sometimes we can't see what the error was because it was rebooted before we got in there, and sometimes you can't, and sometimes you can. But it's better to have them at least check first. There are a number of things that can cause that. One is there can be interference from some of the monitoring systems that log in and out of these controllers automatically. That's part of it. You can have communication issues can drag it down. So similar to what we've seen on devices, you can have, if all of your Linux units go out on the roof because 2 of them have the same address, that's going to weigh heavily on your XCM20R on the HVAC side, right? So when you have a lot of COM losses, it can slow it down. There's a number of things that compound that can drag those controllers into the ground. Some of them can be fixed, and then there can also be hardware issues where they can't be fixed and it needs to be upgraded and it needs to be condemned. But to go through that condemning process, it has to go through that tech support. So unfortunately, there's not a quick fix for it because if it does need to be condemned, it's an expensive fix. But what I would tell you is those are typically escalated when you call them in. So I imagine there's some guys that power cycle them, they come back up, they seem to be working, and they leave. I wouldn't do that. I would call in any and every issue like that just so that it can be researched. Even if it's not completely failing but just running really slow, I'd call it in. It's possible to speed some of these up. It's possible to take some of the noise out. It's possible that it's got old controllers in there that were never properly removed from the system. A lot of hands touch these controllers. A lot of departments, our office, the customers' offices. It really should be investigated. I think one of the things we run into a lot is when there's issues on these controllers in the field, there's a lot of guys that just kind of get them up and working again, even though it was a huge pain, and they leave. And then they'll call us and be like, I go to the store every week and it's doing the same thing over and over and over again. But that's the first time they call it in. And it's like, I get that you don't want to hang around at the store, even if you had trouble with it and you power cycled it and it came up or whatever. When you leave, I mean, on your drive to wherever you're going, call it in. You know what I mean? If we know about it, we can research it. We can get to the bottom of it. We can see if it needs an upgrade. The customer is very willing to upgrade some of these systems if they're repeat cases, but we need to know about it.
You want to talk about the thing that I found out the hard way? Some of the newer anything with an ES1, and you try putting overrides with any board that has the IXO in there.
Yeah, so I had a conversation today about that, actually, because you had brought it up a couple days ago. So the XIO boards, when you're looking at them through the LCD and you override an output on them, they can fault. Now, this is something that my understanding is still being, I couldn't get clarity whether it's been resolved or it's being investigated, but it is something we're anticipating will be resolved soon. We're not sure if it's on the firmware side of the XIO or if it's on the controller side. We understand that these outputs need to be overridden. If you do get a fault, call it in, say that the point's faulted, they'll fix it for you. You didn't break anything. It's an issue we're working through. I'm not sure how much more I can speak on it until we get an actual answer on it.
No, that's fine.
So we are rolling out a new version of Opus. We have new servers going up for it. It's going to be a bit more capable. It's going to have some new features. It's going to look very similar to you guys in the field. We're going to use the same LCD until the other one launches, until the web views launch, which may or may not translate into, tablets or whatever. But until that rolls, well, when that rolls out, I would anticipate this issue will go away by that point. So that should be later this year.
That's fine. I just want to bring it up because I've had it happen to me twice. I was trying to show a technician how the modulate worked on the IDCM module, and how it works. And I overrid it to 10, overrid it to 5, and then went to go put it back to auto. And then it was just like, nope, sorry, we're not going to do it. I'm like, what'd I do? I thought I did something,
So I was on an analog output. It froze up.
Yeah.
Like I said, there's a number of potential causes for that. But yeah, if you're using an output and it faults, call that in. Because not only do we need to know about it, but it is something we're working to resolve. So the more we know about it, the better. So
that web view you were talking about, is that going to replace the current screens, like the remote screens?
It's going to be side by side it for a while. It's only been developed through its first phase, and that's going to be tested by the customer's techs first. And then the goal is to circle back with them and see what it's missing and finalize it, put the remaining pieces in it. We want to make sure that when that does go live to the public at large, it's everything people wanted. We don't want to make, I wouldn't say the LCD we have now is a mistake, but people have not been fond of it. So I don't know what kind of customer satisfaction or voice of the customer they executed at the time, but there's definitely room for improvement. This is going to be a total revamping of it. So on the other side of Opus, it's going to be very familiar. So the people that log in through computers, through a desktop, it's going to look very similar, at least for now. In the future, it will likely be modernized, but we're trying to maintain all of the functionality. We want to maintain as much backwards compatibility as possible, so guys don't have to run out and buy new boards. The hardware you have on site should continue to run on the new system, even if you just upgrade the controller. A number of these ES1s, I imagine, will be upgraded to that new system. So they were ready for it when we sold them initially. So it's pretty exciting because the XEM20R, one of the challenges with it is that thing, when it's fully loaded, is using about 80% of its processor. And when you add in these systems that log into it and pull information out of it, and then you have users logging in on both ends, it can get bogged down. The ES1, I mean, it's got so much bandwidth on it that I've seen these things like fully maxed out and it's running like 30%. So, I mean, we finally have like the bandwidth to deal with any and everything out there for the most part.